Class today. And today we're going to talk about separable variables and separable equations and how to solve differential equations represented this way. And again, this is a topic from Calc 1, Calc 2 of solving differential equations. So a separable equation is a first-order differential equation in which the expression for dy dx can be factored as a function of x times a function of y. In other words, it can be written in the form dy dx is equal to g of x, f of y. Example 1 is the following differential equation separable. So here we see that we don't have any addition and subtraction, so we could factor out. And so we have two expressions. Here's our g of x, a function in terms of all x, and then over here would be our f of y, our terms in all y. So we can go ahead and separate these variables, get all of our y's on one side, then get all of our x's on the other. We integrate, and then we'll be able to solve for the differential equation, just like we did in Calc 1 and Calc 2. So for b, dy over dx is equal to x plus y prime. This is not a separable equation because these cannot be written as factors of one another because of the addition sign. I cannot pull out a y from everything and get terms of y or just terms of x by pulling out an x or of anything. So because I can't do that, because I can't separate these terms, this is not a differential equation. Or sorry, this is a differential equation, but not a separable differential equation. All right, so now let's just go ahead and solve a few of these. This is just going to be a reminder. Make sure you know how to integrate, and then we'll move on. Again, feel free to skip a lot of these. Let me go ahead and say yes and no up here. But feel free to go ahead and just skip through the videos if you feel like, okay, I can take that pretty easy and just see what if there's a mistake, and then you can always go back and watch the video and watch me work it out. So solve the following differential equation. So here what we're going to do is I'm going to go ahead and move everything. I'm going to move the minus y minus 1 squared dx to the right side to get dy is equal to, I'm going to add it to the other side, so it's going to be y minus 1 squared dx on the other side. Now, when all my y's on the same side, so I'm going to divide both sides by y minus 1 squared. So I'm going to get dy divided by y minus 1 squared is equal to dx. Now, what I would do to this problem is go ahead and just bring it up to the top, putting in a negative exponent. So y minus 1 to negative 2 power dy. And on the right, it's just dx. And then I'll integrate both sides. So, integrate the left side, integrate the right side. When I integrate the left side, I got to determine, okay, what's on the inside, what's on the outside. You could do u substitution and say u is y minus 1, u to negative 2 power, and then integrate it that way. So we'd add 1, put a negative there. So we're going to get negative, and then we have y minus 1 to the negative 1 power is equal to the integration of just, that's just going to be x plus c. Again, that plus c gives us the family of solutions. And there's our solution. We can rewrite this as, if we want to, 1 over, put the negative out in front, y minus 1 is equal to x plus c. And there's our solution to our differential equation. Make that negative just a little bit more visible.